Welcome, fact finders, to G Fun Facts Online, the podcast that uncovers the amazing and the awesome. Today, we're not just dipping our toes in the water, we're diving headfirst into a world where our cities and transit systems literally ride the waves. We're talking about navigating the tides of change with something truly revolutionary: floating infrastructure engineering. Our coastlines, the vibrant hearts of so many communities and superhighways for global trade, are facing a massive challenge. You've seen the headlines: rising sea levels, supercharged storms, and coastlines crumbling away. These aren't future problems. They're happening right now, and our traditional ports, bridges, and waterside roads are feeling the pressure. Think about it. More disruptions, more damage, and huge costs. But what if, instead of fighting the water, we worked with it? That's where the exciting field of floating infrastructure engineering comes in, offering mind-blowing solutions that adapt, endure, and even thrive in our increasingly watery world. The numbers don't lie, and the images are all over the news. Sea levels are climbing, and storms are getting wilder, bringing devastating surges and floods that can shut down entire transit networks for weeks, or even for good. Ferry terminals get swamped, port operations halt, and access roads to vital hubs get cut off. The old way of just building bigger, stronger walls is becoming a super expensive, and sometimes losing, battle. So, what exactly is this game changer, floating infrastructure engineering? Picture this. It's the art and science of designing, building, and deploying structures that float, getting their main support from buoyancy, just like a boat, instead of being fixed to the ground. This isn't just about sticking things on pontoons. It's a super smart mix of naval architecture, structural engineering, advanced materials, and environmental savvy. Key ideas here are making sure these structures float safely and stably, no matter the weather or what they're carrying. Then there are clever mooring systems, like super strong anchors that hold them in place but let them move up and down with tides, or even be repositioned. And the materials? We're talking space-age stuff: marine-grade concrete, advanced composites, and rust-proof alloys that can handle salty water, sun, and sea creatures. It's all about understanding how water moves and designing structures that can live in harmony with it, not fight against it. And the applications for our coastal and water-based transit? This is where it gets really cool. Imagine ferry terminals, cruise ship docks, and even cargo facilities that just smoothly rise and fall with the tide. No more constant rebuilding, just continuous, easy access. How about floating bridges and causeways that can handle huge waves and storm surges, or even have sections that can be moved if needed? That's resilience. Think bigger: integrated floating transit hubs connecting ferries, water taxis, and even buses or trains, all bobbing accessibility. Or how about floating breakwaters that calm rough seas, protecting harbors and transit routes, often with less environmental impact than old-school rock walls? We could also see floating fueling stations, maintenance depots, and even floating walkways and public parks, making our waterfronts more connected and fun, no matter the water level. So why go afloat? The advantages are incredible. First off, built-in resilience to sea level rise. They just float higher. This massively reduces flood risk. Many of these structures can be moved or reconfigured. Need to expand? Add a module. Coastal dynamics change. Relocate it. Often they have a smaller environmental footprint than massive land-based projects, needing less dredging and not messing with the seabed as much. Construction can be faster too, with parts built off-site and then assembled on the water. And for tricky ground conditions where traditional building is tough, floating is a fantastic alternative. Now, it's not all smooth sailing. There are big engineering puzzles to solve. Designing for wild waves, currents, and winds to keep things stable is a huge one. Those mooring systems need to be incredibly robust. Materials must be super durable against the harsh marine environment. Connecting these floating marvels to land-based utilities like power and water requires flexible, tough solutions. And of course, Maintenance, regulations, and safety are all critical considerations engineers are tackling right now, but the horizon is buzzing with innovation. Get ready for smart floating infrastructure with AI-driven maintenance and automated systems. Think multi-purpose platforms that combine transit hubs with renewable energy generation, like solar or wave power, or even urban farms. We're seeing new, greener materials and even more advanced modular construction, making things faster and cheaper. Imagine combining these structures with living shorelines or artificial reefs to boost local ecosystems. And get this, very large floating structures, or VLFS, could support huge port expansions or even parts of cities. Plus, digital twin technology means we can have a virtual copy of a floating structure to monitor and manage it perfectly. So as climate change redraws our coastlines, floating infrastructure engineering isn't just some far-off dream. It's a vital happening now strategy. By embracing the water, we can build transit systems that are resilient, adaptable, and maybe even more sustainable. From ferry terminals that dance with the tides to ports ready for tomorrow's storms, buoyancy is guiding us to a new way of moving. The future of how we travel in coastal areas is looking increasingly floaty. Thanks for tuning in to G Fun Facts Online. Join us next time for more amazing insights into the world around us. Until then, stay curious.